Hey everyone, this is MusicTechHelpGuy, and welcome to part 19 of my Music Theory for Producers course. In this video, I want to talk about musical intervals. Intervals are just the distance between two notes. And knowing how to figure these out and identify them can be very helpful for figuring out triads, chords, and harmonic structure. They'll become very important, especially in the next few videos when we start talking about seventh chords. So there's a few intervals that we've already talked about. One was the octave. We also talked about the perfect fifth in the last video when we talked about power chords. But there are a lot of other intervals contained within the space of an octave as well. So this musical intervals chart is something I created years ago when I was teaching a college music theory course, and it shows not all, but most of the common intervals you're going to run into. So in a previous video, we talked about the four types of triads, or their qualities. We had major, minor, augmented, and diminished. Just like triads, intervals have different qualities as well. There's 5 of them: perfect, major, minor, augmented, and diminished. These qualities describe the distance between the two notes of the interval. For example, there's an interval of a perfect fifth between the bottom and top notes of all major or minor triads. Or the distance between the root and the third in all minor triads is a minor third. Or another example we haven't talked about yet is the distance between the root and seventh in a major minor or dominant seventh chord. That's an interval of a minor seventh. So knowing your intervals really helps with understanding the harmonic structure of chords. The way I like to think of intervals is to identify not only their quality, but also their quantity. The quantity is going to be a number between 1 and 8. 1 is a unison, so the same note. You're not going to see many of these. Then a second, a third, fourth, fifth, sixth, seventh, and then 8 is an octave. This number describes the distance between the two notes on the staff. So for example, G and C is a fourth because you can count 4 steps on the staff between G and C. G, A, B, C. 1, 2, 3, 4. Now the C could be C natural, C sharp, or C flat. Likewise, the G could be G natural, G sharp, or G flat. All of these examples and any of their combinations are an interval of a fourth. The quantity of the interval for all of these doesn't change. So how do we identify all these different fourths then? Well, that's where the quality of the interval comes into play. Unisons, fourths, fifths, and octaves can either be augmented, perfect, or diminished. Think of augmented as having the greatest distance between the two notes, perfect is right in the middle, and diminished has the least amount of distance between the two notes. For example, C and G is an example of a perfect fifth. If you raise the G to G sharp, you get an augmented fifth. If you lower the G to G flat, you get a diminished fifth. Raising or lowering notes in the interval, whether it's the top note or the bottom note, increases or decreases the distance of the interval, therefore changing the quality of the interval. So what about seconds, thirds, sixths, and sevenths? These can either be augmented, major, minor, or diminished. This is similar to the previous example, but just with 4 qualities instead of 3. So for example, C and E is an example of a major third. If we lower the E to E flat, we get a minor third. And if we lower it again to E double flat, it's now a diminished third. If we raise E to E sharp, it's now augmented. So figuring out intervals this way is easy if you already know the quantity and quality of a reference interval, but what if you don't have a reference interval? Let's say we have F sharp, and I want to figure out a major sixth above it. There are a lot of methods to figuring out intervals, but the method I use has 2 steps. The first step is to find the quantity of the interval and write it on the staff. So for this example, that's a sixth. We can start on the F space on the staff and count up 6 notes. F, G, A, B, C, D. That's 6 notes, and D is our rough interval of a sixth. The second step involves counting from the bottom note to the top note using half steps to verify the quality of the interval. This is where my musical intervals chart really helps, because it shows all of the half step or semitone spacings for the most common intervals. As you can see, a major sixth is 9 half steps. So to do this, I recommend going to a keyboard or MIDI controller and counting up chromatically starting on the bottom note. Chromaticism or chromatic is a term that describes musical ideas that are derived from the chromatic scale, which uses all 12 notes within an octave. This is opposed to diatonicism or diatonic, where you would only move up or down within the notes of a given major or minor scale. So as we count up from F sharp, we'll mimic that same chromatic motion, including all white and black keys. Also, you start counting on 0 when you count in half steps, not 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the note we land on is either D sharp or E flat. So how do we know which enharmonic to pick? Well, we already determined in the first step that a sixth above any note F has to be a D, so we go with the D sharp enharmonic as opposed to the E flat. So that's the answer. A major sixth above F sharp is D sharp. If we wanted to find a minor sixth now, we could either do it the long way again and count up 8 instead of 9, or we could simply alter the major sixth we already have by lowering the D sharp to D natural. Lowering it down a half step makes it minor. If we lower the D again to D flat, it makes it a diminished sixth. And raising the D sharp up to D double sharp makes an augmented sixth. Note that the only augmented or diminished intervals on my chart are an augmented fourth and a diminished fifth. This is because other augmented and diminished intervals are just not very common. Although one exception to this is the augmented second, which can be used to describe the distance between the sixth and seventh notes in harmonic minor scales. Alright, so now that we know how to do this with the chart, let's do a few more. Let's do a major third above A. We count up 3 from A on the staff and we land on C. Then we look at the intervals chart and see that a major third is 4 half steps, so let's count up 4 from A. 0, 1, 2, 3, 4. And we land on either C sharp or D flat. Since we already established that a third above A is C, we go with the C sharp enharmonic. A and C sharp is a major third. Let's do a perfect fourth starting on D. Count up to 4 on the staff and we'll land on G. Then count up 5 half steps from D, and you'll find that we still land on G. So this one was easy, we didn't have to alter anything. We just verified that a perfect fourth above D is G. Sometimes that'll happen. Let's do a perfect fifth starting on D. Count up to 5 on the staff and we'll land on A. Then count up 7 half steps from D, and you'll find that we still land on A. So again, this one was easy too. We didn't have to alter the top note, we just verified that this was indeed a perfect fifth. There's a cool trick to figuring out perfect fourths and fifths that I like to use. With almost all perfect fourths, the top note's accidental will match that of the bottom, so you can skip the second step. C and F, E flat and A flat, G sharp and C sharp are all examples of perfect fourths. There's 2 exceptions to this though. If the bottom note is F or F sharp, the top note's accidentals won't match. A perfect fourth above F is B flat, and a perfect fourth above F sharp is B. This trick is similar with perfect fifths. For almost all perfect fifths, the top note's accidental will match that of the bottom. C and G, E flat and B flat, F sharp and C sharp are all examples of perfect fifths. There's 2 exceptions to perfect fifths as well. If the bottom note is B or B flat, the top note's accidental won't match. A perfect fifth above B is F sharp, and a perfect fifth above B flat is F. Let's do an interval of a seventh now. Let's find a major seventh above G. So let's count up 7 on the staff, and we'll land on F. According to the chart, major sevenths are 11 half steps, so we'll count up and land on either F sharp or G flat. Since we already established that our seventh has to be an F, we go with the F sharp enharmonic. If we wanted to figure out a minor seventh, we could lower the F sharp to F natural. For sevenths, counting up to 10 and 11 half steps can get a bit tedious, so a trick I like to use is to count backward instead. For major sevenths, instead of counting up 11, you can actually just count down 1 half step, and you'll see that we land on an F sharp in both instances, just in different octaves. For minor sevenths, instead of counting up 10, you can actually just count down 2 half steps. Again, you'll see that we land on F natural both times, just 2 different octaves. Let's talk about how intervals can be used to understand triad structure. In previous videos, I've shown a couple different ways to figure out triads, but another way to think about them is that all triads can be constructed from stacking 2/3 on top of each other with a distance of a fifth between the top and bottom notes. Major triads are a major third with a minor third stacked on top of it, with the distance from the bottom note to the top note being a perfect fifth. Minor triads are the reverse of that. They're a minor third with a major third on top, again with a perfect fifth distance from top to bottom. Diminished triads are 2 minor thirds stacked on top of each other with a diminished fifth between the top and bottom note. And augmented triads are two major thirds stacked on top of each other with an augmented fifth between the top and bottom note. So I realize that this method to figuring out intervals can be tedious and isn't exactly the most exciting music theory topic. However, it's an absolute necessity to understanding chord structure, especially in the next few videos where we'll start talking about seventh chords. Keep in mind that the goal here is not for you to continue to have to look at a chart to figure out intervals. It's that eventually you'll internalize all of this information after using it for a long time, and it takes years to internalize all of this. When I write my own music, I'm not thinking about notes and keys and scales and intervals. It's all internalized, so I don't have to pull out some chart to figure things out. And the same can be said about the first 18 videos in this series, and any future videos in this series as well. It's not something you're going to memorize overnight, but rather something to internalize, like learning a language, over years and years of use. And one last thing I want to mention, just like chords, intervals can be inverted too, but I'll save that for a later video when we start talking about writing harmonies to melodies. I hope you guys enjoyed this video, and thanks for watching.